Hi there, my name is Michael Wharton. I am a senior machine learning engineer at KUNGFU.AI, and today I'm going to be talking to you about our first open source project, and it's called Kaishi. It's currently released to the public. You can access it from the command line. There's documentation and a variety of different resources to help get you started, but I'm going to go ahead and go through a really quick tutorial to just kind of help you kick the tires a little bit. But a short little bit about Kaishi. It's meant to be this library that helps you accelerate the time it takes to get from a raw data set, something that you might receive from a client or some pet project you might be working on, all the way to a proof of concept. These projects we often find have a lot of really common menial tasks that end up happening between getting that raw data set and then transitioning over to something that's more useful for downstream tasks. So we saw that as an opportunity to help accelerate our own internal processes and also provide some tool that's useful for the community at large. One of our core values is that we like to be open about what we do. So in that spirit, we've decided to open source this project. And as such, it is a community project at this point. So if you decide you want to contribute or you have some sort of pull request you want to make, feel free to. You can reach out to us and we'd love to collaborate with you. So let's go ahead and get started with it. Kaishi is a Python module. It's pip installable. So we'll go ahead and pip install it. I already have it installed here in this environment, so it was obviously pretty fast. It'll take you a little bit longer, but it shouldn't take too long. And Kaishi is meant to be operated on a directory of files. That's really the only prerequisite for using it. It's meant to be interacting with a lot of different data types. There's a lot of core functionality that applies to just files in general, regardless of the data type. And then there are also two submodules that are currently implemented. These are for tabular data and for image. So this image submodule is the one I'm going to be going through today because it's probably the more mature and the most performant of all of our submodules. But there's a lot of functionality built in elsewhere as well. And as we build on our own internal processes, we'll be adding to this continuously. So I think you could expect a pretty continuous improvement of this library. So it'd be good to just keep up to date with it. So let's say you have Kaishi installed here. I have a little image data set that I put together. It's a subset of 600 images that are all from the Pascal benchmark. If you're familiar with image benchmarks, you'd probably be familiar with the Pascal data set. But in short, it's just 600 JPEG images that are from a variety of sources. They contain things like cars, scenery, people, pets, just a lot of common objects that are in images. And it's meant to cover a wide swath of what you might see in an image. So you can interact with this in a Jupyter notebook or whatever environment you like working in. But just to keep things simple, I'll go ahead and do it right here in the command line. So let's start Python. You'll notice that there's a pattern between all these submodules. The first entry point into using Kaishi is just going from, you start from Kaishi and then you index into whatever data type you might need. And then there's always a data set underneath that. And then you import the specific data set type from it. So that was the image data set object. But in the same way, you can import your tabular data set object. Or there's only one that's a little bit different, and it's our core module. So in the core module, you'll import a file data set. And each one of these operates in the exact same way. A lot of it's meant to cross over from data type to data type. So a lot of the methods that you'll see today that aren't image specific, it's available everywhere, no matter where you are in the project. So let's go ahead and initialize a data set here. We're going to use this image dataset class, and then we'll go ahead and give it a period to denote the current directory. And you'll see it popped us up with a warning here. A couple of the pipeline components use this underlying, it's actually a ResNet 18 to do a couple of labeling tasks. And if you don't have a GPU installed, which I don't, I'm using a laptop right now, then it'll get you this warning. It's worth noting that all of the deep learning models that we have included and continue to add to this project, they're not meant to be this end-all be-all that's going to be this perfect model that has the absolute best validation accuracy you could possibly have. They're meant to be these really quick hints at what might be present in your data set, especially when it's too much data to just manually analyze. So they'll still be kind of fast with your laptop, considering that they're deep learning models. But if you have a GPU, that's obviously better. So let's go ahead and run this file report method. This is a good home base to kind of report back and see how everything is in your data set. And you'll see, it looks like we actually have 601 images since it's 0 indexed. But yeah, these are all images from Pascal like we mentioned. It'll show you the file name here, children if there are any, and labels, and as well as these filtered files. We haven't really run any processing yet, so none of that's populated, but you'll notice that it will be here shortly. So let's see how to look at these files. Every dataset object will have a files list, so we'll look at the first object, and it's a Kaishi image file object, but whenever we represent it, it just spits out the file name here. And then you'll also notice there's another way to interact with this. You can use keys to interact with file names here. And it just returns the same object, so that's just more of a convenience for you. Let's go ahead and run a dir on this to see what might be contained within it. And you'll see there are a lot of internal methods here, like limit dimensions, there's a patch, there's convert to grayscale, compute perceptual hash. These are all methods that are kind of used under the hood that are meant to help all the other pipeline components of Kaishi. I mean, unless you're a power user, you might not really need these. But if you want to dig into the API documentation, you're more than welcome to use them. I'm not really going to cover them today, though. We're going to cover the more macroscopic, how to create a pipeline and run it. So with that said, actually I should also mention that as by default, whenever you initialize a data set, the only thing it does is read in the file structure. It doesn't provide any loading or anything like that because that might take unnecessarily long. There are certain pipeline components you can run that don't require you to load the images or tabular data if you're in that corner of the repo or anything like that. So it's meant to be just kind of an efficiency measure. So if you did want to load all of them, you can run this load all method, but we're not going to do that because whenever you run a pipeline, it'll do that for you. So let's look at what pipeline options we have. These are all the pipeline options we have. You'll notice they all start with a very particular keyword. If you go into the documentation here, there's under user guide, there's a pipeline component section, and it kind of gives you an overview of how to create your own pipeline components if you want. But those consistencies that you see there come directly from these criteria for developing your own. So I won't go into too much detail there, but suffice it to say there are very particular rules that you should follow to create pipeline components so that they're usable by these dataset objects that perform operations on themselves. So let's go ahead and configure a pipeline. Whenever you run this configure pipeline method, you can give it just a list of strings that refer to what the pipeline methods are that you want to run, or I should say pipeline components. So let's check out this filter similar pipeline component. We've configured a pipeline, and now if we look at it, you see there's this, so this is the 0th pipeline component, and then underneath it you'll see an indented list. Sometimes there will be more depending on the pipeline component that you're using. But in this case, there's one configurable parameter, and it's the perceptual hash threshold. This is a number that corresponds to how loose you want your similarity measure to be between two images that are being compared. I'm not going to go into too many details there, but if you want to look at the API documentation, it'll point you in the right direction to hint you at how these pipeline components work. So that's pretty much it there. Let's go ahead and run it, and you'll notice it'll take a little bit of time because it needs to load all the images, and it actually needs to compute that perceptual hash, but it's not too long for 600 images here. So now let's look at this file report again, and you'll see that there's a variety of images that were actually filtered out, and it looks like we filtered about 16 judging by the count here. So some of them were similar, some of them weren't, and we should write a quick loop here to just detect which ones were similar, just to kind of show you what happened here. So let's do for file in. Oops. So we're just checking to see if a certain file that we have has children. Actually, I should say, let's see if this works. Yeah, that's, oh, I see what I did. Let's go back up here. Let's try this. There we go. So we got an image here. Let's go ahead and open up this one. Looks like it's a picture of a sailboat with a horizon in the background. And let's see what this similar image was that it detected. So you can see it detected that these two images were similar, and that kind of makes sense here as well. There's a horizon that's roughly horizontal. They're in approximately the same place. There's some boats in it. And yeah, you'll notice that sometimes this similarity metric doesn't work perfectly. So as I mentioned before, it's meant to be this indication to help nudge you into knowing a little bit more about your data. But in this case, it seems to have worked really well. So now we can also use this. If you look at this pipeline and you look at the completed steps member, you'll see that it shows that we completed a filter similar step, and then it shows you the configuration that we ran on it. So now I'm going to show you a different way to initialize a pipeline. So we're going to use the same configure pipeline method that we used before. However, we're not going to give it any arguments. You're going to notice that it gave us this prompt to initialize reading of basically a list of integers that indicates to it which pipeline components it needs to add. So let's add a new one. Let's go to, let's filter by regex. This is the file name. We'll filter duplicate files, invalid file extensions, image headers. Let's go ahead and convert to grayscale, and let's leave it at that. So you'll see that it printed out our pipeline here. And you'll notice that not all of them are configurable, but we have a pattern that we can configure for this filter by regex component. And then there's a list of valid file extensions that comes preloaded in this filter invalid file extensions component. So this pattern here basically renders this filter useless by default. It doesn't filter out anything, but let's go ahead and configure it. Let's say we want to filter out any image that starts with the year 2012. So we'll say, we'll look at this pipeline, and we'll look directly at the components, and we'll go into the 0th index because that's where this filter by regex lives. And then we'll say configure, and then we'll say we want this pattern to be 2012, and then we'll give it a wildcard, and then it's configured. So let's look at our pipeline again. There we go. So that pattern was successfully configured. And if you wanted to, looks like I got a meeting there. So if you have a list of file extensions that are a subset of this, or a different set of extensions that you want to filter, you're more than welcome to change that in the same way that we just configured this regex component. But I'm not going to do any of that here. So we'll go ahead and run it now. And let's run our file report here. So now you'll notice that it looks like it picked up this .dsstore file here. That happens when you have a lot of, or happens on Mac a lot. You'll notice those files kind of creep into your directories. And I've actually had that throw a kink in some downstream operations for machine learning tasks. So in this case, that probably helped us avoid a little bit of a pitfall there. And then we have these similar files that we filtered out before, those 16. And then we also have a lot of these files here that were filtered out that started with 2012. So that worked, and now we're down to 514 images because we have this 0 there. And then you'll notice that they all have a label of grayscale now, which is what happened when we did this transform to grayscale. So let's just check this pipeline and look at the completed steps. And you'll see now it's got a list. It starts with that filter similar that we ran first. And then from there, added these other components that we ran. And everything's as expected here. So I'll go ahead and save it now. Once you manipulate your data set, transform it, manipulate it whatever way you might want to, you can just give it an output directory and it'll save it for you. We'll get out of our Python terminal here. And then we're in the same directory, so let's list files, and we'll see we have this output directory that's created. So let's go into this output directory. Let's see how many files are in there. 514, that's about how many we would have expected. And then let's go ahead and open a few of them and look at them. You'll notice that none of them start with 2012, which is great. And let's open this list here, and you'll see that they're all grayscale. There weren't very many of those similar images that were detected, but theoretically, if you ran that step, then you should notice that there's a lot of variety in your image data set now, which seems to be what we're getting here. So that's great. There's a lot of other functionality there, and there are a lot of tools built in for you to kind of explore. I would encourage you to go to the documentation here if it's something that you want to check out. And if you've got any questions, feel free to reach out to us. We're on various social media channels, LinkedIn. You can go to our website here at KUNGFU.AI. That's a good entry point to get in contact with us. But yeah, thanks for listening, and we hope you enjoy the product. Appreciate it.